Hello teacher, today I want to give my final report. These two figures are respectively the result of opening the executable file with a grid number of 1111 and 2222. The circle in the red are their respectively iteration numbers. These three pictures are the opening the executable file comparison of value of each grid number, and these are the value of opening notebook to compare each grid number value after comparing with previous values. In order to save computing resource, I choose the number of grid 8181. And this picture is present the temperature description. And this is discuss the number of iterations with different realization values. We compared the case of 161 grids number of found that the larger relaxation can get smaller number of iteration. This is also a way to save computing resource. The following are the calculation resource of non-uniform grids. We use 4181 grid numbers. The following results are the temperature description diagram, execution file resource, and resource after opening notebook. And this is my coding. Next, the paper I want to report today is applying CFD for designing a new food cabinet dryer. I have divided my presentation into 5 parts. To solve the short of cabinet dryers, they designed a new type of cabinet dryer to obtain a uniform description of drying airflow and temperature. There are 7 cabinet dryers with different structure for experiments. And then below is the main objective of this research. Next, materials and method divide into the following type. Design of a new cabinet drying chamber. The picture on the right is a sketch of 7 dryers with different structures selected after research, and below are their respective dimensions. And then basic governing equation for designing the cabinet dryer. These 3 control equations are mainly used. And then this is tray simulation. To solve the governing equations, initial and boundary condition must be defined around the boundary of system. Since the equations are highly nonlinear, they are not be solved by explicit closed-form analytical methods, and then is experimental apparatus. And then resource and discussion. The picture on the right is the temperature description profile for the 7 design. We can see that both of B and C designs show reasonable uniform air temperature description in the drying chamber. The next one is the air velocity profile. The 3 designs B, E, and F all perform well in terms of velocity description. Therefore, B seems to be a best taking into account all considerations such as a simplicity in structure. The results of statistical analysis show good correlation between the predicted CFD and the experimental data, and analysis of experimental data in duration of days of dryer chamber did not show a significant variation, so 2-dimensional CFD model was propitious for this study. Final conclusions. First, CFD was a very powerful tool for a cabinet dryer system analysis. Second, the side-mounted planar chamber improved conventional cabinet dryer well. Third, the standard K epsilon model using empirical data showed very accurate results. And then design B was shown to be a most suitable design for obtaining uniform air temperature and velocity description in a drying chamber. Last one, sharp angle alpha. Do not recommend for the side-mounted planar chamber. Above is my report. Thanks for your attention.